My name is Jan Wilczek from WolfSound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 25th episode of the WolfTalk podcast. Today I have a very special guest for you, namely Julian Parker, an audio programmer and researcher from the UK. He obtained his PhD from the Aalto University, then he worked for many years at Native Instruments, then he switched to TikTok, and now he's with Stability AI, working on the state-of-the-art cutting-edge research related to music generation using deep learning and transformer architecture. So all this, audio AI generation stuff here and now on the podcast. So in the podcast, you'll not only learn his story, but you'll also learn a lot of behind the scenes of the audio research stage and the audio companies stage. And I think it's something that's not found very widely on the internet. So this is very unique interview from someone who had insight and has insight into both audio research and this whole world and audio companies, audio plugin companies. And I think it's amazing that Julian is so generous to share what he's been through, his experiences, and to give everyone who doesn't have such easy access to this kind of information. I also asked Julian a lot of questions related to conducting successful research and in general succeeding in the audio industry. I also asked him the question whether you need to have a PhD to work in a research and development department at an audio company, and specifically when it comes to AI-generated music. And all the resources that he mentions related to music generation and audio programming, all the people, places, references are listed in the episode notes at thewolfsound.com/talk025. So once again, it's thewolfsound.com/talk025. And before we jump into the interview, I just wanted to tell you that if you would like to help the podcast, if you benefit from the podcast, then please subscribe to the WolfSound channel on YouTube, give a thumbs up to this video, and consider leaving a 5-star review on Apple Podcast or Spotify. Also, if you'd like to see a specific person on the podcast, leave this suggestion in the comments on YouTube. Thanks a lot. Finally, I'd like to mention that if you'd like to become someone like Julian, then I have a resource just for you. It's my free audio plugin developer checklist that you can get at thewolfsound.com/checklist. It lists every bit and piece of knowledge that I believe is necessary to become a full-fledged audio developer. So once again, get your free checklist from thewolfsound.com/checklist. And now, Julian Parker. Hi, Julian. Thanks for agreeing on this interview. Could you introduce yourself to the audience?
Hi, Jan. Thanks for asking me on your show. I'm Julian Parker. I guess we're going to talk about a bunch of other stuff, so I don't need to give a proper introduction. But yeah, I work in the music tech space and have done for around 15 years.
Nice. So how did this start? How did your interest in music start? Were you playing some musical instrument?
Yeah, it's an interesting question. I think in my family, so I come from quite a musical family. Like my dad plays the guitar, my mum plays the guitar, and I grew up hearing music throughout the house when I was going to sleep or in the day or whatever. But I think when I was growing up, they thought that I was the technical scientific one, because that was mainly where my interests lay. So I didn't learn an instrument when I was a young kid, but what I did have was basically access to my dad's old recording gear. So he had things like a reel-to-reel tape player and, cassette decks and all kinds of different stuff. So even when I was like 8 or 9 or so, I think I was like playing around with this reel-to-reel tape recorder, like cutting bits of tape up, like recording things off the radio and then splicing them and stuff. So like I kind of got interested in sound pretty early. Also, yeah, I have distinct memories of playing around with tracker software on computers when I was like 8 or 9 as well. I was lucky / unlucky. I don't know which way to put it. So I didn't have any like games console or anything when I was growing up. I had a ZX Spectrum, which was super outdated at the time. Like I'm not that old to have been young when they came out, but like this was what we had. Which is a super cool computer because it means that you have to program, you have to learn that. But it had interesting tracker software on it, like which you wouldn't have got on like a PlayStation or a SNES or whatever. So I remember messing around with that when I was really young as well. So so I did have this interest when I was like a child. Around the age of 15, I kind of managed to convince my parents that maybe I was interested in music. Actually, and I could do that as well as like other stuff. Well, I'm making them sound really draconian here. That wasn't the case at all. But yeah, when I was about the age of 15, my dad gave me one of his electric guitars. It was a Yamaha SG. And I didn't get along with that at all. Like that was really frustrating. Like, cause, I don't know. I didn't do well at learning it. So I kind of got annoyed and decided I wanted to be a synth guy instead. So I sold that guitar and bought a synth, a Korg Prophecy, actually. So an early kind of virtual analog synth, and just kind of went from there in the synth world. Actually, I bought a lot of my gear in the period of between like 16 to 20, maybe, because stuff was still cheap then. I had a Saturday job. I could look in the paper for stuff that was advertised cheap, buy it cheaply, like drive down to London or whatever, pick it up, and then like flip it again for a little bit more. So I managed to build up quite a nice synth collection in that time. Yeah. So I did get into this stuff when I was still like a teenager or a child. Actually, I think things came full circle a bit then. So I didn't touch the guitar again for many years until I kind of decided that was some unfinished business during the pandemic. And then I bought an electric guitar again and learned to play, and it went much better this time. So now I like synths and guitars, but there was a long period in which I did not touch a stringed instrument. But yeah.
Awesome. So I'll add this to the list of my questions, like of doing research and doing work, and also like learning the instrument on the side. Okay, cool.
I mean, very different parts of the brain in those different activities, right?
That's a fair point. I need to remind it myself maybe more often. But there's always a keyboard involved, and I guess since you were perceived as the tech-savvy type, you were then more adjusted to keyboard.
Yeah, maybe. And I guess I just like I think what I liked about synths, apart from being into electronic music at the time, like I was very into like Aphex Twin and Warp Record stuff and like the dance music at the time. Apart from like that being the sound that I heard in the music I was listening to, like I was always more interested maybe in texture and timbre than I was in like playing very technical melodies or something. So like synths are much more useful in that respect.
I understand. So did this interest in synthesizers kind of guide you into what you studied in college?
Maybe a little bit. So, Well, I mean, so at high school and, well, UK college in the UK is actually something that you often do before university, right? So college is where you are when you're 16 to 18.
Okay.
So I was mainly studying the stuff that I was good at college. So maths, physics. I mean, it did have some like tangential relation to synths. Like I can remember I did a physics project on FM synthesis and like made a bunch of patches on a Nord modular to like illustrate different like FM synth things, and then and actually made the same patches with like hardware function generators in the physics lab and stuff like that. So yeah, it was kind of influencing me off there to the side. But yeah, like when I was thinking about what I wanted to do for a career at that time, I thought that I wanted to be in astrophysics. So that was my goal. And I got into a physics course at Cambridge. Well, natural sciences is what they call it there. It's kind of mixed together with other sciences. And you don't really say no to that if you get in. So that seemed like a sensible way forward at that time. So I went off to Cambridge to study physics. And, you know, music was more of a hobby at that time. So I was still making bits of stuff and like running some club nights around town in Cambridge and DJing and stuff. But like my professional / academic focus was on physics at that time.
Okay, and do you still remember what was your bachelor thesis then about? Like, did you write a bachelor thesis at the end of your bachelor's?
I mean, so the theses are not such a big part of the bachelor's process, at least in the UK. I did have to write like a research report, which was on some, oh gosh, I haven't thought about this for a while. I think I was writing something about whether you could predict different things about how like sections of the visible universe had evolved from like the fractal dimension of the patterns of radiation that you were getting from that section of space. I mean, I don't know. That wasn't, you know, that didn't go anywhere really conclusive, but yeah, I guess that's kind of my first bit of research. No, we did a little bit of research in the college before university as well, but yeah, it was, yeah, that was the topic.
Okay, nice. So then, because afterwards you went to get a Master of Science degree in Acoustics and Music Technology at the University of Edinburgh. And what motivated this decision?
Well, there was a little bit of a gap between those. So I left Cambridge. I didn't see a way forward necessarily staying in physics because, I mean, it's really interesting. But I wasn't really sure that I necessarily wanted to be an academic. And I don't know, it just didn't seem the path at the time. So I did what like a lot of people in their early 20s do, right? And like you try and chase your dreams, or at least what you think your dreams are at that point. So I had a brief time, like 1 to 2 years of trying to be a musician and a producer, trying to get some traction on that. And then that wasn't working super well. So then I had a brief time doing music journalism. And yeah, that was also fun for about 3 months and then just got a bit, I don't know, I didn't like it. So I ended up, yeah. So I spent a couple of years kind of feeling around for what I wanted to do. And then by chance, I guess, came across this master's in Edinburgh. Which bizarrely was kind of designed for people with my backgrounds and interests because it was basically a physics course for people who wanted to get into music adjacent things. So, yeah, I mean, during a physics course, you learn how to solve differential equations. And then this course was like a big part of it is solving differential equations that are related to musical stuff. so that fit really well. I mean, it also had a really interesting kind of crossover component where you did projects with, courses and projects with a couple of other connected masters, so a sound design masters and also a digital composition masters. So that was super interesting for me, having not had any arts education, because like I did some sound installations, like we did like compositions, like formal computer music compositions, like, so that was like an interesting little exposure to the world of arts education, which kind of, I mean, it's still crazy to me that you can do these two things at once in one degree. But I guess I was really lucky that was the case.
Okay, now, so in general, you did find the course really rewarding and interesting.
Yeah, exactly. And it still exists. So, I mean, if anybody's listening who is thinking about going to the University of Edinburgh to do that course, then I would highly recommend.
Okay. And there, I wanted to ask, because your master's thesis was exactly on virtual analog modeling of spring reverberation. And could you share maybe a little bit what was the motivation for this work and which approach to modeling did you take?
I mean, so that came directly out of this idea that I just talked about of like solving differential equations of things that are musically related, which just so happened to be, that's like the main topic of Stefan Bilbao, who's the professor there in that department. So the actual spring idea, I think I even mentioned it in my original interview for that course, because it came into my head as something that hadn't been studied. Like it's a very distinct mechanical system, and it's quite important to the aesthetics of a lot of music genres. So like most guitar music wouldn't sound the same without spring reverbs, like dub reggae, like different 60s stuff. It all uses spring reverb heavily. But at that point, nobody had really kind of studied why it sounded the way that it did. It was just all, wishy-washy descriptions. And maybe some people like thinking about it from a very pragmatic engineering point of view, but like there was no work on like, okay, why does springs have this special sound? So that was my original pitch the original pitch for my thesis there was not so much modeling. I mean, it's modeling as a scientific activity. So it's modeling as a way of understanding how something behaves and why it behaves that way, and making the connections between the physical mechanisms going on and the sounds that are produced. It wasn't really aiming at, making a plugin or something. And the approach we took there was purely like a physics-based approach. So it required deriving / digging around in old papers from the 60s to get a decent set of equations of motion for the spring that weren't simplified in such a way that all of the interesting audio qualities were gone, and then doing numerical simulations of them, which is basically solving the differential equations to look at different behaviors and how different physical parameters affected the sound. And so that was the result of that thesis, basically a very early digital model of spring reverberation, but not intended for real-time use or anything like that, just intended for offline use.
Okay, and which numerical method did you choose for solving the equation?
I mean, finite difference schemes.
Okay.
So it's really just direct numerical integration of the PDEs involved. It was fun, very mathsy, but interesting.
Yeah, I can totally imagine. And this work was also a base for a handful of then following research publications on spring reverberation.
Yeah, I mean Yeah. Sorry to
to
jump over you. I mean that topic led directly into the PhD thesis. So I mean, I got lucky there, I guess, because I finished my master's thesis and was wondering what to do. And then my supervisor at Edinburgh, Stefan, who I mentioned already, he was like, "Oh, well, I know these guys in Finland who are interested in this kind of stuff, and they might have some PhD funding at the moment. which sounded attractive to me. So I went across to Finland, met Vesa Valamäki, who you also know, of course. Explained to him my work so far and, the things I thought I could do in a PhD. He was really into it and had some money. So, yeah, this was the days before Brexit as well. So it wasn't actually difficult to move to a different country in the EU to study. Like, there was not really, I could just go, basically. Like, he had money to pay me. I was happy to go. So I just went. And of course, like any PhD, like you go in with some idea of what you wanted to do, and then it evolves over the time you're there. And I'd say springs were a big part of what we did, but things kind of went off in slightly different directions as well, because so Vesa was less of a solving differential equations guy and more like a signal processing guy. So, in order to collaborate with him, effectively, like we kind of shifted the approaches a bit away from like the physical, like direct physical modeling angle to more like real-time signal processing type solutions. And yeah, so we did a couple of spring models in that vein. And then a big part of these spring models was all-pass filters. So filters that don't attenuate any frequencies, but delay them by different amounts, which is really important for the sound of a spring. And then the research kind of went in that direction. So it went from springs to using all-pass filters to do different signal processing things. Like we even had a paper on doing like dynamic range compression with all-pass filters, for example. Various stuff that was connected with all-pass filters. So, and it ended up the thesis topic. Well, the nice thing in Finland is that you don't do like a monograph thesis. It's not like a big book that you write at the end. It's just a collection of your papers with an intro tying them together. So I had this pretty decent through line through all my research of like dispersive systems. Dispersive means that different frequencies travel through them in different speeds. So that was kind of the topic in the end. Like it's a collection of papers about different signal processing and music-y usages of dispersive systems.
Okay, nice. And when we're talking about papers, like, do you still remember how was it like to write your first paper? So what you mentioned, like you started quite early, right? With this work, and like, was it difficult for you, or was it easy after your experience in music journalism?
I don't think that helped at all. It wasn't that early. I was, let me think. I was 27 when I started writing my first paper, which was like the first Spring Reverb paper. To be honest, that was like a distillation of my master's thesis. So in a way, my master's thesis was the first research paper. It's tough to get it over the line because you don't know the writing style yet. You don't know what's important in the paper. But I don't know. I didn't find it overly difficult, and that's probably because I had really great mentors and professors around, like both Vesa and Stefan, like writing the papers with me. So, they would stop you going down a blind alley, or, make sure that you knew what was important. I didn't find that like a particularly taxing transition at the time somehow. But that's, like I said, that's thanks to good support, I think.
Okay, that's very, very kind of you. But yeah, I can also attest that Vesa is a very good supervisor when it comes to writing papers. So exactly. I can definitely feel you there. And speaking of papers, I really wanted to ask, because during your PhD you co-authored a paper that has been widely cited, and I would describe it as very, very successful. And this was a paper on artificial reverberation, a reverb paper. It was called 50 Years of Artificial Reverberation. And there you catalog the approaches to modeling reverb, or like to generating reverb using various methods. And I was curious to ask, what was the idea behind the paper, and could you maybe tell why do you think it turned out so successful?
I mean, so that's, I think that's borderline. I mean, it's not a traditional research paper, right? So it's a review paper. The idea, well, and the credit for that goes to Vesa again. So he's been in that world for a long time. He was, well, and is prominent in IEEE. He knew that the 50th anniversary of the first reverb paper was coming up, which was from Manfred Schroeder. Okay, sorry, not the first reverb, the first digital artificial reverb paper. Obviously, people have been thinking about acoustics for hundreds of years, but or thousands even. Yeah, so he knew that anniversary was coming up, and he knew that if we asked the IEEE if we could write a big review paper for it, they'd probably say yes. And there wasn't really a review paper in the reverb domain. So like, full credit to him there for spotting an opportunity, and also having the connections to pull all those people together, because there's some pretty eminent people on that paper. Like I'm the newbie on that paper, to be honest. Like I mean, there's Julius Smith, there's Jonathan Abel, there's Vesa, there's Lauri Savioja, who's really big in acoustic stuff and room acoustics. So I was just very, very lucky to be able to join that, I guess, as the expert on like electromechanical reverb stuff. But also, I mean, a lot of my contribution there was like editing and organizing and like pulling everything together from the different people. So yeah, I'm very glad that we did that. I can't really take any credit for the genesis of it, because that's totally Vesa, and that's totally him knowing when it's the right time to do something. But yeah, it's great. I mean, it's adds to your citation count, which is only a positive thing.
Yeah, I also highly encourage everyone to read this paper, because I think it's very approachable and super interesting also to start, implementing this stuff on your own.
I think we need a 60 years or 65 years one soon, though, because there's been huge like movements in the reverb research space since then. I would say, like, people like Sebastian Schlecht have done amazing work. Yeah, so somebody needs to do a new review paper. Probably not going to be me, because I'm pretty far away from reverb right now, at least.
Yeah, so I think there was also like a follow-up paper, right? Like more than 50 years of artificial reverberation, but
yeah, that's true. That was one update already. Like I think 5 years later, maybe, or a bit less. Yeah, for sure. But yeah, that was kind of my last engagement with reverb in an academic sense. That paper, actually. So I haven't really done any spring reverb work after that, or reverb work in general in an academic context. I did do lots of making reverb work, but I guess we'll talk about that later.
Yeah, exactly. We'll jump to this in a minute. I just wanted to ask you, like, how did you find living in Finland in general?
I love it. I mean, great place to live. I absolutely adored my neighborhood. I mean, I'm married to a Finnish person now, so
Awesome.
Yeah, I enjoyed the Finnish culture. It takes a little bit of time to break into, maybe, but once you're in, it's very, very rewarding. It's a beautiful place, clean air, the sea, trees. Yeah, I like it. I hope to go back one day.
Awesome. And how is then the lab different from the lab at Edinburgh?
I mean, it's hard to compare directly, because I think as a master's student, you're not, well, okay, in Edinburgh, Yeah, there was a really good community in Edinburgh around the master's course, but the PhD students were more separate, doing their own thing. And actually, Stefan had only just started there, so he only had one PhD student at the time. Um, so there wasn't really a lab as such at that point, although there definitely was later on in Edinburgh. But when I was there, not so much. Um, well, and also actually in Finland, it changed vastly over the time I was there. So when I first started, I kind of caught the tail end of like a huge group of, or a huge cohort of previous PhD students who were then doing postdocs. I could mention a bunch of names, but I guess it's we don't want to necessarily go too deep. But that was interesting. So they were around for the first couple of years. Also, Matti Karjalainen, like the legendary professor who basically founded that lab. He was still around. He sadly died around, I think, a year and a half into the time I was there. So it was kind of the end of one era in the acoustics lab. And then we had like maybe 1 or 2 years where it was kind of just me and Vesa and people doing spatial sound as well, like those guys. But like it was mainly just us. And then like working on our like the physical modeling part. And then things picked up again. And a bunch of people, new people joined towards the end of my time there. And it was very much a lab feel again. But I mean, I think it's like any research group, like the size shrinks and grows depending on like the availability of funding and good students. And, you know, sometimes it's very quiet. Sometimes there's lots of other people to talk to. Yeah, it just changes over time. I mean, it's always good. Each era has its own advantage. Like when it's quiet, then you have more access to professors. When it's busy, then you have more great colleagues. So, you know, it's all good.
Nice, thanks. So, after finishing up your PhD thesis, you went on to work for Native Instruments in Berlin. So, can you tell us the story? How did that happen?
Yeah, so I mean, towards the end of my time in the PhD, I'd also started doing some virtual analog work, like electrical virtual analog work. So I did some stuff on, particularly filters, like this Buchla filter and some other things. And that's obviously a topic that's very interesting in the music tech domain, usually. I mean, what was the one catalyst for me going there? I knew a bunch of people from Native as well. So at DAFX DAFX I guess your listeners know what DAFX is, right? It's a very good conference in this space. In DAFX in, I want to say 2010, but it might be 2011. Anyway, there was a DAFX in Graz, and I met this guy, TJ Hertz, there, who's still a friend of mine, otherwise known as Object. He's quite a big producer in the dance music scene, kind of legendary actually for the last 10 years. He was working at NI at the time, and he was at that conference, and we hit it off and hung out a lot. So I had and he was working in research there, so I had some connection to that department already. They kind of knew who I was. Actually, weird random story. So that, particularly at that DAFX, there was a main hangout group of me, TJ, who went on to be this big successful DJ, and Colin Raffle, who is like a legendary machine learning guy now. Like he's responsible for the T5 text embedding model. So like, you know, big machine learning name. But at the time, like we were just all random like students essentially hanging out at a conference, in Graz, going to the bars and stuff. So yeah, weird. But yeah, so I had some connections to NI. I mean, also a couple of the people from the research. So we often had people from industry coming over to visit us in the lab in Finland. So we had people from NI, so Egbert and Steinon. We had people from Yamaha coming. We had people from who else came? Korg, maybe? I can't remember. Anyway, there was lots of people visiting because Vesa had such a prominent position in the field, and people in town would come and visit him and meet the students and stuff. So yeah, people from NI came to visit. We were just giving a presentation about work from the lab, so they saw some of my stuff and they liked it. And basically, yeah, when I finished, or when I was getting close to the end of my PhD, they just reached out and they said, well, hey, do you want to come and work in our research team in Berlin? And yeah, it seemed like a good idea. So I didn't really question that. I just went with it. Didn't apply for any other jobs, actually. Just went across from Helsinki to Berlin for the interview. I mean, I'd been to Berlin before. I liked it as a city. That was a nice opportunity to go and live there as well. Yeah, and join Native Instruments. At that time there was a research team. So I joined a research team. But I guess the conception of research at that point was a bit different, because the research team was responsible. I mean, it wasn't pure research. It was making algorithms for products. So that's what was meant by research. So I joined the DSP part of that research team. There was also an MIR part who were doing, like extracting information from audio, because that was a very nascent topic at the time. I joined the DSP part, who were basically making the algorithms that go into the synths and the effects at NI. Yeah, and things just went from there. So I mean, that's what I did. I made a bunch of algorithms. I mean, what was my first project at NI? Actually, my first project was a limiter, which ended up in Machina and Tractor and a few other places, I think. Basically, we had a limiter already in the company, but it distorted too much. So I spent a long time thinking about how to make a limiter that would distort less, which is not a super easy task. But I mean, I eventually landed on this idea of using the analytical signal. So maybe your listeners know what that is. That's like the complex extrapolation of a signal. It's like what the signal would be if it was represented as a complex number. You can produce that using like very special filter banks, essentially. And once you have that, you can get an estimate of the amplitude of the signal that doesn't involve like the instantaneous amplitude variations associated with phase. So for like a sine wave, you can estimate the amplitude in this way, and it's just constant instead of going up and down, like you'd expect for like if you were doing like a peak follower, like just in the waveform domain. So yeah, I made that limiter. I think my second big project was a reverb, an FDN reverb, which went into Machina, and then later, very much later, I revived it and improved it and turned it into Realm, which was one of the most popular plugins. Yeah, I made all kinds of stuff, to be honest. I mean, I guess reverbs were a big focus. So maybe I missed a spot. I missed a tiny little bit chapter in this story here. So before I went off to NI, I actually did, I think, 3-4 months working on under some funding that my good friend Till Boverman had secured. He was at that time a researcher at what's called Taik in Finland. So that was the arts university in the arts and design university. He was working in the media lab there. Later that merged with my own university in Finland to become Aalto. Actually, maybe that had even happened at that point. Anyway, so he had a project going on to make sound art stuff that could be interacted with by people who would normally have trouble interacting with this stuff. So, yeah, all kinds of different situations. So he was basically making like the interactive, like the actual kind of designy part, and then I was making algorithms for him to put into this system. And at that time, I made my first like professional sounding reverb, or set of them actually, in the Faust language, actually, weirdly. and then released them. We released them open source as Super Collider Hugens. They were called, well, one was called JP Rev. It's a bit arrogant of me. And the other one was called Grey Hole because it was kind of inspired by the Eventide black hole. But like that's where I learned a lot of reverb tricks. So I did a lot of reading around that time about like lexicon, elasis, like all kinds of like deep reverb lore, and like first made some good sounding reverbs. And interestingly, these two open source reverbs still get used quite a bit. Like I had a guy messaging me like last year wanting to put Grey Hole into some products of his. Like they've been ported to like Norms, the Mono Norms platform, and like they turn up in all these different open source situations because there's not a lot of good sounding like open source reverbs out there. So I just thought that was worth mentioning. So I wasn't, when I got to NI, I wasn't going into the like musical reverb topic blind. I'd done a couple already, and then my first big project, the limiter was kind of a small project. The first big project I did, and I was making this really good sounding, as good sounding as I could possibly make, FDN reverb, which ended up going to Machina, and became RAM eventually, as I said. What's the train of my thought now? I mean, there's so many products I made during that time. Like it's almost hard to remember them all. Like we did reactor blocks, so I did a lot of the filters for that, and like a filter building toolkit, as well as some of the module design. We did Replica, which was like a really successful and like pleasing one for me. So that had some reverb stuff in it. But I also did a bunch of nonlinear, like vintage sounding reverb stuff in there, like and a very novel kind of delay algorithm, which people seem to really like. People still like talk about that delay a lot as being one of the best plugin ones. And so I guess a couple of years into my time at NI, the company restructured a bit. So the research team was dissolved, and people were spread into product teams instead. I mean, luckily for me, I ended up in the effects team. So it really didn't make any difference to my day-to-day work. I mean, we had to be a bit more product focused, I guess, and a bit less academically focused, but essentially like the day-to-day was still the same. And we did a bunch of really interesting effects during that time. A lot of if anybody's familiar with the NI product catalog, we did these packs. So we did like the mod pack and the crush pack, and like a bunch of like individual small kind of interesting takes on bread and butter effects. And how many of those did I do? I think I did about 50. No, did I do 4 of them? I did a bunch of them, mostly myself. Obviously it's a team thing, so you're getting feedback and like working with other people. But there was like maybe 4 of them that I led on. And that was quite an interesting time. We were putting out these packs of 3 effects quite regularly, and the turnaround time on each one had to be like 2 or 3 months, but they also had to be interesting. So, that was quite a busy time. So in that effects team, I guess we built up, or I guess I built up a little bit of like institutional capital at NI. I'd also been publishing papers and stuff. And at some point I felt I had enough, I guess, political pull to kind of float the idea of having a research team again, which didn't happen immediately. It took, saying the same thing and again for quite a few years. But in the end, we managed to get that established, with the idea of basically starting to use more machine learning techniques in the kind of work that we were doing. And the first big project, the kind of project that we used to sell this was basically automating the task of virtual analog modeling. I mean, I haven't really talked about this so much, but it was a bit of a bottleneck for the company, right? So it's not every kind of effect that you want to put out, but maybe 50% of the things that you want to do, especially if you want to do like guitar software, like Guitar Rig, will be virtual analog effects. And it was like a real bottleneck in our process, because doing good virtual analog stuff requires like a really weird combination of skills. Like you've got to be able to do the maths. You've got to be able to tune it to sound like the real thing. You've got to be able to code it up, make it really fast. And basically we didn't have that many people who could do it. It was me and a couple of other people who were able to do this work, but we had other stuff to do as well. So like if we wanted to do, for example, like a Guitar Rig update or something, then, and they wanted like 5 new amps and like a bunch of new pedals, it was just not possible. So I thought, hang on, maybe we can automate this. And came up with this proposal and kind of a proof of concept of how we could do that. And then this research team was built out to like make that a reality. So I mean, I'd been in a kind of pseudo leadership position before that. So we had these things called chapters within the company. So I led a chapter. Like I was kind of the guy leading all of the audio algorithm related stuff, but I didn't have my own team until that point. So at that point, we established a team, a research team to do this, and got some new people in, and tried to make this automated guitar modeling stuff a reality. That actually happened. So just as we were ramping up on this, the pandemic started. So that kind of made things a little bit more difficult than they would have been otherwise. But no, we did it. I mean, we got that out there. That's the technology that powered a lot of Guitar Rig 6 and 7. I mean, there was many kind of long days measuring like high voltage amps and like packaging data, learning how to use like cloud platforms. And I mean, it's an amazing experience, to be honest. Like there's nothing else to do in the pandemic. Like none of us had really done like production scale machine learning before, or even really worked on the cloud, because we were like C++ developers doing audio applications. So it was great. Like we could just like concentrate on learning this whole new area and making it work. It's a good time. So that was kind of my entry into machine learning, I would say, although I'd been paying attention and reading papers in the background. I mean, and that team also worked on a bunch of other machine learning related stuff, a lot of which sadly never came out, which makes me sad, so I can't really talk about it. But I guess that's also the time when I first got into generative stuff, like audio generation for musical uses. Sorry, I'm aware that I've just gone on a massive monologue here, so maybe you want to make sure I didn't skip any of the burning questions you had.
No, that's awesome. I'm just making notes like crazy. This is like super interesting, and I think like these plugins are not signed in any way and in any obvious way. So I think it's super interesting to learn like all the projects that you did there.
I'd say they're not overtly science, but my approach, maybe this is me being selfish. My approach was that I'd almost never do something the way it was normally done. I would look at how X type of effect had been done before, read all the papers and be like, okay, what can I do better? So there was always a researchy science bit before, in order to try and get some kind of competitive advantage and, make something that could potentially be the best in that category. I don't know if that was always a success. That's obviously subjective, but like that was the approach that I would take. So it wasn't completely non-sciencey or researchy either. That feeds into the product process, I think.
Okay, awesome. Yeah, I totally agree. Like it's not, but I respect it a lot, because a lot of the times I see, even in research, like kind of copy pasting, right? So it's like take things from this, and this paper and tweak it a bit, and maybe they'll publish you. But like thinking of a like significantly more novel or better in some way approach is then definitely a way to go, and definitely quality research and quality products go out of it for sure.
Yeah, I mean that's kind of my modus operandi. Maybe in some situations it's not the way you want to go, but like for me that's what makes me happy. Like if I can rip apart something, like come up with a better way of doing it and then do it and it's better, then that's a happy place.
Okay, but at the same time, like it's not easy, right? So like as you said, there are like three components. So one, there's like learn all the existing approaches, read all the papers, and I think a lot of people could stop halfway through it, and then thinking what can you do better is also not so obvious. It also requires a lot of structured creativity in that sense.
Yeah, I mean, I think we talked about this in the pub once before, but I don't know. Like, I wouldn't say it was that structured for me. Like, usually I would just get good ideas by going on a walk, or like when I was in the shower or something. Like, it's about input in the end, right? So as long as you're excited and interested about this stuff, then it's always going to be buzzing around in the back of your head. So once you've read stuff and understood like the status quo, then you don't even necessarily need to do something active. You just sit on it for a while. And then one day you're going to be walking to the shops to get some milk or whatever. And you're going to be like, oh, wow, like, yeah, I could do that. And then you've got your idea and then you can go and chase it. So, I mean, it's creativity, right? So it's similar to the artistic process, which is often not like I mean, obviously there's a graft element, but there's also a random element of just things. Your brain makes connections subconsciously and things come to you. And then you have to, I guess the bit that's really, that you learn to be good at is curating your own ideas, because you're going to get 20 ideas and then maybe 15 of them are not going to go anywhere. So you have to start developing some intuition for which ones actually have some mileage and which ones are probably not going to go anywhere good. But yeah, I think it's not so different from other creative activities, research.
Okay, nice. So I wanted to ask, because for me it's really interesting, because you jumped from academia to industry. Of course, your role at NI was more research flavored, but at the same time, as you said, it must have been product oriented. It wasn't just pure research and writing papers. So my question is, what did you need to learn when you landed at NI? So before working there, did you have any experience in C++ or creating plugins?
I've done a little bit. I mean, so I made a bunch of plugins during my PhD times to demonstrate algorithms. They were usually made with like Max for Live GUIs, and then the DSP backend was usually like Gen or Faust running inside MSP or something like that. So, and I've always been comfortable with programming, so none of that is an issue. But yeah, I wasn't really heavily using C++. I mean, I'd done some project work. For example, we made iOS apps in one course during the PhD, so I'd done a bit of C++ there. But no, I would say I learned the majority of it at NI. I mean, the thing is, so in a way, writing DSP code is a great place to learn a language, because there's a bunch of constraints around the way that you do things. Like most of our plugins, for example, only ever had like static memory allocation. So as soon as you don't have to do any memory management, like C++ is much easier, right? Like you just declare all your stuff at the top of the class, and then you use it. So in a way, it kind of provided like a simple entry into that. And and then you make stuff, and then you get better at it. I mean, I don't know if I consider myself to be like a great C++ programmer or anything. I've never been particularly into like the latest standards or anything like that. Like I don't particularly derive any pleasure from it as just a language in itself. Not to say that I wasn't using modern features, of course I was, but like I was always more the type of person who wanted to just write very clean, clear code that was easy for somebody else to read and understand, rather than trying to use like really advanced techniques. Like clean, clear, and as performant as possible. So I kind of aimed for that. But yeah, I basically learned that on the job. And with the plugin environment stuff, I mean, again, that was kind of like the infrastructure provided by the company made that pretty easy, because we had like our own internal plugin framework. And to make a new plugin, you just basically had to copy a load of boilerplate, then fill in some specifications for like what parameters you're exposing and stuff, and then write the DSP code. So it wasn't really difficult. I mean, having said that, I did also do some juice stuff, like in my first couple of years at NI, just for prototypes. So I learned a little bit there as well. But yeah, I mean, I didn't personally feel like that was ever something that you couldn't just learn on the job. But again, like I suppose it's a bit like the paper writing thing. Like if you've got good people around you who've done it already, then anything's easy, right?
Yeah, that's true. That's definitely true.
Because you can just ask a question. Like you do something, it works, or if it doesn't work, you're like, hey, like, why is this not working very well? I should give a shout out to Eddie, actually, Eddie Mond, who was still is at Native. He's one of the original Guitar Rig developers. So I guess I learned quite a lot of C++ from him. Like he's, he deserves credit for that part.
Nice. And like you also needed to learn this, as you said, high performance C++. So do you remember still, were there any resources, I don't know, or libraries that you found particularly useful in the journey?
I mean, we used our own internal SIMD library, which is obviously a big part of doing high performance stuff. To be honest, very little external facing stuff at all. Later on, well, okay, no, actually, that's not entirely true. For example, for building the reverb I mentioned very early on during my native times, so FDN reverbs are very matrix heavy. So I wanted an easy way. I didn't want to rewrite like efficient matrix multiplications, because that's a massively solved topic. So yeah, for that kind of stuff, for matrix heavy things, for a long time I used Eigen, which is a great library for doing this stuff. And then that got heavily used later on when we were doing machine learning stuff. So obviously we weren't going to deploy like Python, PyTorch or TensorFlow code. I mean, you can do, but like it's not performant enough. So like we again went back to Eigen then when writing like C++ implementations of neural network stuff. So I guess Eigen was a big one, yeah. But apart from that, it was mainly, I mean, you have very small components. We had our own like internal library of DSP components, basically, that you would contribute to when you were making a new effect or whatever, and then you could pull stuff out of there for other projects, so that you didn't waste work doing it again. And yeah, the standard was usually pretty high in terms of quality and performance. So. But yeah, in terms of external stuff, we didn't really, so it's not very useful to people wanting to get into this area, but we didn't really use any external libraries. No.
Let's pause here for a moment. In the answer to the last question, Julian mentioned that at Native Instruments, they had their own framework for creating plugins. Quite a few audio companies have their own plugin frameworks to easily allow them creating various audio plugin formats out of a single codebase. Back in the 90s, there was no alternative. However, now developers have access to a few open source plugin frameworks. The biggest and the most popular of them is Juice. Juice is an open-source, cross-platform C++ application development framework that makes it easy to create audio software, as well as audio plugins and plugin hosts. You can write code once and build VST, AU, AUV3, AAX, and LV2 plugins on Windows, macOS, iOS, Android, and Linux, as well as embedded platforms. I've been successfully using Juice since 2018, both in my private and professional projects, so I'm delighted that they're sponsoring the podcast. I especially like how Juice makes it easy for beginners to jump right into creating audio plugins and applications without worrying about C++ quirks. Juice is used by the majority of the world's most important audio companies, but it is free for personal use and there's affordable pricing available for companies just starting out. Apart from the framework itself, Juice has an amazing community of users gathered in the Juice forum, which is a great resource to learn audio programming on its own. Most recently, the Juice team has released Juice version 8, which contains many new features, including WebView plugin UIs, which is very exciting. To start using Juice now, go to juice.com, download Juice, and follow their Getting Started guide. I have also put a link to it in the description. Have fun creating audio apps and plugins. And now, back to the interview. Okay, and I think also it was nice that you could always look into this library of DSP components and see how other people have done things before you, and then you could somehow, model your approach on the tricks used there as well. I think it's it's an awesome thing, and I'm glad that more and more things are getting open source so that other people can benefit from them as well.
Absolutely, and actually, so I didn't really talk about Reactor here. So I did work on Reactor for a while, building Reactor components, and Reactor is an amazing historical library of DSP because it's been around since the mid-90s and people have been making good DSP components for it for that entire time and mainly uploading them for free on the user library. Well, and we also had very, experts in Reactor internally, like people like Vadim Zavolution. So that was probably another important learning resource. You could, if you wanted to think about ways you could do something, you can always go and search around what have we got in Reactor? How is that done? Or if there's something that people really like the sound of and is really hyped on the user library, what techniques are they using and stuff. I mean, that's a bit of a translating that into React is very different to C++. So making that transition between the two could be difficult, but it's an interesting place to look for inspiration.
Okay, thanks. So maybe one last question about NI was that for me it's not clear how much your research output during that time was purely NI driven and in comparison to what you did on the side.
Yeah, I don't want to. I want to give them enough credit there because they didn't stop me publishing, but the majority of that was kind of under my own impetus, mostly written during evenings and weekends.
Okay, so that was my question. How did you manage to combine this? Because this work at NI was challenging enough, and then yet you also published your own research in your free time.
Sure, but it's not constant, right? So usually there'd be a bit of a rush in the few months before conferences. It's okay, have you got an idea? Make that happen. So it's not year round you're working evenings and weekends and stuff. It was more just for maybe 1 month out of the year, you would do more work. And I also enjoy it. And I wanted to be still in the research community. And I also made my feeling, and I think it's turned out to be correct, was that I would have a better career if I had a good publication record, because I mean, you can say anything about what you did in a company, right? But like a first author paper out there with like some interesting idea that other people are citing, like that's a very, very clear indication of whether you're competent or not. And I felt like if I continued to put research out there, like it would just help me to continue doing interesting things and earning money from that. I mean, not to say that it was like, that wasn't like the main motivation, but like that I could see why I might want to spend a few hours in the evening working on something. Like it felt like I was getting benefit from it.
Yeah, it's kind of expanding your portfolio in that regard.
Yeah, exactly.
Yeah. Plus, you also found it interesting.
Yeah, exactly. So, there's plenty to recommend there.
Yeah. So during your times at NI, you've published a number of papers concerning virtual analog modeling for your circuits. And could you maybe share briefly which virtual analog method have you found most useful or most interesting?
I mean, I was always a bit hardcore about VA stuff. And I was also mainly for that stuff working with Fabian Esqueda, who you know as well, I'm sure. And we kind of had the same approach to that. So we didn't really apply any of the like methods as such. We would just write down the equations, manipulate them by hand into a set of differential equations, and then solve them. So pretty much the same method. Well, okay, they're ODEs instead of PDEs, but pretty much the same thing I was doing with springs or whatever, like way in the past. That was always the approach. That's probably because we both were influenced heavily by Stefan and did the same course at Edinburgh, so we liked that approach. But yeah, so I was always following this kind of manual approach. Maybe that's why I also felt like virtual analog was too labor intensive, because I was taking the hard route. But yeah, that was my preferred. I mean, it's also because I never really liked the idea of like just cranking the wheel and like getting a model out, like, but in a manual way, right? So I didn't want to follow like a prescribed set of steps and just get the result. I mean, that's my own. I don't know if that's my own ego or something. Like I wanted to know what each bit was doing and understand it, and like have a little bit of scientific insight into what was going on. Not that you can't do that any other way. I don't know. It's subjective. It's personal, right? Like,
yeah.
I enjoyed doing it that way, so that's what I did.
Okay, nice. And so was this then? Was this the reason why neural networks were for you so attractive?
Yeah,
like in comparison to these labor methods.
Well, neural networks are basically like big DSP systems, right? So designing, if you're used to dealing with big DSP systems, of course you have different things are important and they're used in slightly different ways. But at the end of the day, like it's a big network of like components that do some processing on data. So like switching from thinking about DSP systems to neural networks was not that difficult at all, to be honest. Like that's like it's a very similar task. So that was attractive to me because I felt I had something to contribute there, because that's not necessarily machine learning, and AI is a kind of domain where a lot of people take an out of the box network architecture or something and then pump in some different data to it and they get a result. And that's great. That's 100% valid. But I felt like I could also get somewhere by looking at architectural stuff. And I could contribute something in that domain that would potentially have more impact than, like I love doing DSP work, but like, especially like audio focused DSP or music focused DSP, it doesn't have a huge audience necessarily, at least academically. I mean, it's big enough. I don't want to like put it down, but like if you want to like if you enjoy like thinking about architectures and thinking about these kinds of systems and you want to have an impact, then it's, at least at the moment and also 5 years ago, worth doing that in the machine learning space. So that kind of attracted me in. I mean, I think it was also just a little bit like unexplored territory, right? So you've got like this huge like new technological revolution, and it's going to make it possible to do things that people hadn't dreamed of before. And wouldn't you like to be a part of that? And try and direct it in an interesting direction. I think it's just, you follow what seems interesting at the time, and hopefully you have some knowledge from what you were doing before that makes that transition relatively painless.
Yes, I think you've used your skills from the DSP domain. You put those skills to great use and combined it effectively with kind of black box neural network approaches, in the sense that you did not just blindly, apply the same stuff just to music, but like you took, okay, what's the difference in the musical field, and how can we really use neural networks to our biggest advantage here? But the thing is that what I find a little bit funny is that actually your work was kind of pioneering in this area when it comes to digital audio effects. And that's precisely because there was, and I feel that there still is, a lot of skepticism when it comes to machine learning, especially deep learning. Some of the more conservative researchers in this area are a little bit, against this, let's say, it openly hype on deep learning, and treat it a little bit, like a thing for, kids or something not for mature research. And so obviously not everyone shares your opinion on being able to put something valuable in the DSP space with machine learning. So that's why I think it's worth underlining that your preliminary work was not something that was obvious at the time, although there was a hype on deep learning, but definitely not in the audio effects space.
I mean, any research area has kind of a momentum or a weight associated with it, right? Like a lot of people like to continue doing the same things that they've always done and thinking about the same things. I'm personally not that kind of person, as you can probably surmise from me, like jumping to new areas like every so often. Like I like to learn new things, and I like to, like, if something stays the same for too long, then I start getting like restless. Maybe it's like, I don't know, maybe maybe I have some problem. But like, yeah, I don't know. I also wouldn't place value judgments on techniques. Like, I don't think like deep learning neural networks, they're just a tool. They're a particular way of formulating like certain types of problems. I don't know why you would make a judgment about whether it's the right thing to do or not without trying it out and seeing if it brings you any advantages, right? I try and keep an open mind is what I'm saying. And maybe that'll be another thing in 10 years from now. Maybe I will be making quantum. Well, I mean, people are already doing quantum stuff like for music. Haven't gotten that train yet, but there's always. It's nice to try and follow the frontier of what's going on a little bit. You know what I mean? Because that's often where the most interesting problems are, especially if it's a new space. Because when you're in a new space early, then I guess, like you said, then there's interesting things that you can do, and you might be, I mean, not necessarily first, but you might be concurrent with lots of other people doing similar things at the same time.
Yeah, for sure. And speaking of which, then in 2022, you started working at TikTok Research. And I think it's a very interesting transition. And could you maybe tell a little bit how did this happen, and what were your duties at TikTok?
I mean, I just came out of being in Berlin for a long time and having, I mean, I don't want to say I'd done everything that was possible to do at NI, because that's absolutely not the case. But I'd done a lot of things, and it felt like time to try something new and focus maybe more on the machine learning and AI stuff. And TikTok at that time had a team in London that was basically they'd acquired this generative music company called Duke Deck, a London-based company, a couple of years before. It was run by Ed Newton-Rex, who's still pretty prominent in the music AI space. Lots of other great people there. They'd been acquired by TikTok and had built like this symbolic music generation research team. So this is the days before we were generating musical audio. This was people were generating notes in MIDI. So they had this team doing that in London, and they wanted someone to continue that research in a more like audio focused direction. So I joined to work on that, which was quite good timing, because I remember early on in my time there, I was like, guys, we've got to make like DALL-E for music. Like, this is possible. We've got to make DALL-E for music. And people were like, nah, come on. It's ridiculous. And then about 2 or 3 months later, everybody was like, oh my God, we have to make DALL-E for music. Like this. And then Music LM came out, like everything exploded. Like, so it was the right time to be doing that stuff. And, it's a great team there. Met some wonderful colleagues who are still great friends. And we got an opportunity to do some early work in that area. I mean, unfortunately, a lot of our really early stuff wasn't able to be published, partly because we're playing catch up with Google and co. Like, there'd be a new model that would come out, and then we have to see whether we can do something similar, and then blah blah blah. But I mean, then also, we were able to find our own direction and do some novel work. So that's the things that went into the STEMGen paper that I put out last November, like trying to push this technology in a direction where it makes more sense for musicians to use. Like, it does something that people want. Like, I still think, so, this might seem strange because I work on text conditioned music generation in a broad sense. I still do. I don't actually think text is a very good medium for musical expression. I think that's an opinion I've held all the way back to my brief time being a music journalist. Like, it's really, really hard to write about music in a sensible way. Certainly most musicians do not think about music in terms of words. So whilst that is an incredible magic trick, like it's an incredible thing that obviously caused a huge buzz because it was absolutely not possible in the past. Like, I don't think that's the end game of this technology, because using it in actual music production process, that's not really what you want. You need something that fits what you're making already, either by specifying beats, key, blah, 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 or by letting it listen to what you're doing and react appropriately. So that's what we were doing in STEMGen. Wow. What was the original question? TikTok. So I was there to make AI systems for generation of musical audio, and we did that, and we tried to push it in a way, in a direction that was useful for musicians. And I'm quite pleased with that project. I'm sad that we could never put out the weights or the older code, but that's often the way if you're in a big company. It's just not possible. So and that was that was part of the reason why I jumped to my current company, so Stability AI, which is also a very prominent AI company, lots of resources, lots of great people working there, but with a different and more open attitude. So, it's actually fantastic to be as a place to be at the moment, because the kind of baseline, the assumption is that most of your work will be published and potentially released open to the community as well. And that's quite gratifying to me, because all of my favorite projects over my career so far have been ones that have been accessible to the community in some way. Like, whether that's been for example, some of the free Christmas gifts we put out, like plugins we put out at NI, or papers or open source stuff. Like, I'm not a huge product's personal capitalist. So I'm not really bothered about how much money is being made by the thing as long as I can still continue working. But like putting things out there that people can use and make something with and like give something back to their own journey, like that's what gives me personal gratification. So I'm very lucky to be in a place right now where that's prioritized, which is great.
Awesome. And at Stability AI, I understand you continue your journey with generative music. I think you've lately published this open model, right? So stable audio.
Yeah, we published two big things. We published two big things recently. So one was we had a new version of our closed behind an API music model, which was, I think, academically interesting because up until then, people have been generating like 30 seconds or maybe 90 seconds and not really like coherent long form music. And we managed to come up with a model that can do, full 4-minute length songs with structure and stuff. I think that got a little bit of a bit lost in the current like commercial hype around other platforms that do similar things. But academically, we were the first. So that was great and significant. Yeah, and then we took this same model structure and trained it on a public Creative Commons data set gathered from WolfSound, like with the express purpose of giving something back to the community that other people could use. So, and not just to use directly, but also to build on to make their own fine tunes that they can use in the music production process. Just to start a bit of an ecosystem around that kind of model. So that came out like just over a month ago. No, just under a month ago. And hopefully that's going to be the start of many other interesting things that are built off that particular model. I'm really happy we're able to put that out as well because, obviously there's a lot of conversations around data and like legitimacy of different data sources in AI right now. And we kind of took the approach of like, okay, if we want to put something out there for the public to use with the weights available, what's the best way of doing that without stepping on people's rights? You could just go public domain, fully public domain, but you have a very limited set of music then. So we chose to go for Creative Commons, like specifically Creative Commons, CC0, which is like public domain, or CC by attribution. So that means you can reuse that work as long as you credit the original author. So that's the approach we took. We used like CC by and CC0 data from WolfSound, and then we have a giant attribution list distributed with the model. So everybody who contributed, like everybody who has a sound in that training set, is listed in that list. I forget if we listed them by name or whether it's IDs of their WolfSound sounds. But anyway, there's an attribution pathway that goes directly back to them. And to us, that seemed like the easiest way of putting something out there that was kind of respecting the spirit in which the content was shared. Obviously, CC licenses predate machine learning. So there's definitely a conversation to be had there about whether that needs to be, like whether those licenses need to be refined and revisited now that training is a thing. And I think that conversation needs to happen. But in the world we live in right now, that seemed like the most ethical thing that we could do if we wanted to put out this kind of model. And people seem to have responded well to that. So it seems like most people agree with us on that particular point.
Nice. And I do understand that it's difficult to navigate this area, and there are a lot of controversies and also misunderstandings still present. So I'm super curious to see how it develops. And
it's an exciting time.
Yeah, wish you all the best in this vein as well. And still in this topic of generative music, then I wanted to go back to this StemGen paper that you've published this year, which is based on your work, if I understand correctly, that you've done at your time at TikTok. And I was, curious also to ask, what motivated this shift in your research interests. So like you were doing virtual analog modeling using deep learning techniques, and then you shifted more towards generative music. So was it motivated by the kind of duties you were supposed to do at the company, or was it purely internal?
No, I mean, so I briefly touched on this. We had some plans for generative stuff in the research team at NI, which never came to fruition because I think it was a bit too early. The techniques weren't fully there yet. And, it wasn't in the zeitgeist yet. So that didn't pan out, but that was something I'd been thinking about and working on for quite a while. So it wasn't actually like a direct jump like that.
Okay.
But it's also just about what I said before. So like, it's an interesting area. It's an area where there's a lot of things that haven't been done before. There's a lot of unexplored territory. And it's possible to make an impact. And it's interesting as well. So it's partly like wanting to seek an area where you can do things and have those things be meaningful. And the other bit is that it's obviously an incredibly powerful technology. And, I've worked my entire career. So in the industrial part is like, 11 years now. In that entire time, I've been making tools for musicians to make their lives better. And, this is an incredibly new powerful new technology. I want to do my bit to steer it in the direction to it becoming something like that. Like I want it to be something that makes people's music production lives easier and better without taking away the joy. So I feel a little bit like, not exactly a moral obligation, but like, I feel like I want to do my tiny part in pushing things in the way that I would like to see them ending up. And that's not going to be, that has to be done now. That's not something that can be done in 5 years or in 10 years. Like this stuff's happening now. So it's the time to work on it and push it in the right direction now, if that makes sense.
Yeah. Yeah. And touching on this, like, could you share briefly maybe what was then, how did you approach this problem in your STEMgen architecture? So like, what was novel there and how was it then received?
I mean, STEMgen, the big difference in STEMgen is that there's no text conditioning, although there could be. If you have the data, there can be text conditioning. And actually, Sony did a really good paper called Differiff recently, which is kind of like a diffusion version of STEMgen, but with text conditioning as well. But yeah, the novel thing about STEMgen was the focus was not on like following text prompts. The focus was on making something that was more like a collaborator, more like a musician. So also not like style transfer. Style transfer is like an old thing in the music AI space. So that's where you take something and then transform it into the same thing, but with a different style. I didn't want to do that. What I wanted to do was something that was in a way creative. So something that could listen to what you were doing and then react to it the same way that like might happen if you were like jamming with a friend in a band, or if you send like a half finished song to like your buddy in a different city and then they do some synths on top and then they send it back or whatever. I wanted this feeling of like collaborating with the system. Because that seemed to me to be a much more interesting method of control. Because that's, in the end, that's a big part of music, right? Like, not for every piece of music, because some things are entirely solo, but like in general, music involves like bouncing ideas off other people or even other systems and getting something back and like feeding off that kind of like back and forth and iteration. And I wanted something that allowed that. And that kind of required changing the training paradigm completely. So, I mean, needing STEM-based data, for example, like so that you can separate things into like different submixes and like explore the relationship between them. So we kind of came up with a new training paradigm where you provide like context audio, and then you generate things that are complementary from that. I mean, there's a bunch of architectural novel stuff in there as well around like, it's basically like a non-autoregressive language model, which is kind of is one of the rarer types of generative model in the the current AI space. I think unfairly, because it's actually a really promising direction. A lot of the big stuff at the moment is either autoregressive language model type approaches, or it's diffusion, which is not autoregressive, so it's not just looking in the past, but it's using continuous representations usually instead of discrete ones. Like the non-autoregressive language model style approach that I chose for StemGen is kind of in between those two. And that gives you a lot of like advantages that you can't get from the other two quite so easily. And we did some work to like try and make that work better for audio generation as well. So that was a very gratifying paper. I'm glad we managed to get that out there. And the reaction, you asked about the reaction. It got a good reaction. So I was actually surprised. So I just put it up on Archive like last November, and then suddenly I was getting all these like people reaching out to me about it. I mean, I think partly it's because I'd made videos to go with the release and the demo. Like people like videos, but it's also because this legendary machine learning guy on Twitter, AK, he works at Hugging Face, but he publishes this list of what he thinks is the coolest research that comes out on Archive every day. And he'd somehow managed to see my paper and thought it was cool and posted it. So then it got a lot of exposure. Yeah, and the reaction was really good. I think, I mean, we saw that also a little bit with the reaction to our recent Stable Audio Open release, which was focused on not generating like full music, but generating like samples that you use in music. Basically, anytime I've put out something that is addressing a musician's needs instead of trying to remove them from the process, then people love it. I mean, who would have thought? Isn't that a strange idea? Like people like it when you do something that's useful to them. So yeah, I'd say the reaction was good because of that, and long may it continue. That seems to be the right direction to take.
Awesome. So at this point, where we reach the present, I would like to move a little bit into more technical questions, if you allow.
Sure.
So you mentioned a few, types of a few approaches to this kind of generative modeling. Autoregressive, non-autoregressive. You mentioned large language models. You mentioned diffusion models. And my general question is that I feel that, there are a lot of people who, see this hype and want to be also part of it in a way. And if someone wanted to start, working on generating music with deep learning from an implementation point of view or from a starting point for their own research, which resources would you recommend to learn this new and emerging field?
So I'd say the thing to do is to go out there and start playing with open source and open weights models. So if you're interested in language models, then Llama or something like this. If you're interested in music and audio, then Stable Audio Open is a great place to start. I mean, just because of the resource constraints, you're probably not going to be training your own models from scratch as someone new to the area on your own laptop or even on like some cluster that you've rented at like certain cost per hour. It's much better to start from publicly available base models. I mean, and there's huge communities around these things. So in the language model space, like there's a massive open source community around Meta's Llama models, around the models coming out of Mistral. And there's people fine tuning these models. There's people making up new applications and ways of using these models. It's hard to even say where to start because there's so much. I mean, a lot of this work goes on Discord, various Discords, but like looking around GitHub, we will find stuff as well. In the audio space, I think our base model is a great place to start. We also have all the code available. We have our own library for training these models called Stable Audio Tools. And we actually have a Discord server called Harmony, which I guess we can post a link to with all this content, where there's a bunch of people like messing around with these models, trading them on their own music, like trying to do new stuff with them. And in the image space, there's also a huge community around Stable Diffusion, which is similarly actually mostly on Discord, but also GitHub. I mean, I can't say much about that space because I'm not deeply in that community, but like, it's actually an incredibly, compared to getting into doing DSP, there's so much more activity and there's so much more like, resources out there for this stuff at the moment. It's much easier. Like there's lots and lots of people who are tinkering with this stuff in their spare time in their bedrooms. So yeah, that's the way to get into it. Just, download a model, try doing some inference, try like fine tuning it on your own data, maybe trying, a new method of interacting with it, or like, the sky's the limit really. But yeah, it's really about, I think, taking pre-trained base models and playing around with them. If you want to get into training base models, then that's harder because you need resources. And it's also hard to develop intuition about training base models just from doing small. Actually, I had a conversation with a colleague who's mostly done DSP from another music tech company recently, who was just getting into this kind of stuff. And he had exactly the approach that I would expect from a traditional DSP person or engineer, of being like, okay, let's build this up from small to large. Let's start training on like 100 samples, see where that goes. Like, let's see what happens when we do 500. And I kind of pushed him away from this because AI doesn't work like that, unfortunately. You will, like, conclusions that, like, smaller models are harder to train in many ways than large models. I mean, it's not hard to train a small model with not much data to overfit and just reproduce inputs, but that's not what you want, right? You want something that's actually creative. And to do that, you need a lot of data. So doing experiments on small amounts of data and extrapolating from that doesn't necessarily get you that far and can actually give you kind of misleading conclusions about what's important. So that's a bit of an annoying, depressing conclusion for people who want to come in and train base models, right? So I guess what you have to do is get really good at engineering, or come up with new ideas and manage to get into a company that has the resources, or a university lab, actually, that has the resources to have a go at training this stuff at the scale that's necessary. I mean, people do this. Like there's one guy on Twitter or X or whatever you want to call it at the moment, who's on his own basically training a state-of-the-art image generation model to compete with Stable Diffusion. Like one guy on his own. I mean, he's got a grant for some compute that he's managed to get from some generous person, but like, that does happen, but it's rare. So building base models is normally like a group activity with resources. And you'll see that with things like Llama. Like Llama 3 has like a credits list that's like pages and pages long. Like it's had a team of hundreds working on it. Like these things are big and expensive and require like a huge amount of person power and compute.
Yeah, definitely. I can see that in all the modern deep learning papers, the list of names is typically very long. So even in your StemGen paper, it's like 9 people credited there. So
yeah, sure. I mean, that's also partly just my
generosity.
Like you always have a core, you have a core team working on a paper, and then you have people who have been involved. And like, I tend to feel like it doesn't cost you anything to include someone if they've contributed something. So like, I know some people try and keep authors lists shorter and then just put people in the acknowledgements. I tend to just put people in as co-authors because why not? So, I mean, that's also something that happens. So, like, different areas have different citation approaches now, or different author list approaches. Like, I mean, in big physics labs now, I think CERN is the famous one, right? Like they literally list, I think, everybody who works at CERN every time they put a CERN paper out. Maybe they even randomize the order. I kind of like that because research, whilst it will have someone driving it, like it's always a group effort, right? Like there's always people contributing to various degrees, and like it's important that those people get recognized.
Okay, nice.
And it's important for people to understand that this stuff is a group activity mainly.
Okay.
I don't like this traditional idea of like the solo mad scientist or auteur like doing all the magic on their own. Like I think most of the time that's complete rubbish. That's not the way it works. And anything we can do to fight against that narrative is good.
Okay. And this leads me a little bit into my other question. So how would you say, like for a research and development position in the audio industry, do you need a PhD right now?
It depends on the role, I think. I mean, I've hired plenty of people who haven't had PhDs, usually with a master's. But having said that, like AI specifically at the moment is incredibly competitive.
Okay.
So you're maybe at a disadvantage if you don't have a PhD. I mean, if you have something else that makes you stand out, like some great paper, then it doesn't matter if you have a PhD. Like if you have some great papers, but you haven't got a PhD, then whatever. You've already proven that you can do good research. Yeah, I know it's always a tough one because it's like a huge chunk out of your life. And then, like, is the area still relevant by the time you finish the PhD? Who knows? Like, the world changes so quickly. What I would say to anybody who's thinking about that, like, I didn't do a PhD to get a job, right? And probably if you're doing it just to get a job, then you shouldn't do it. Like, you need to do it because it sounds like your idea of heaven to just be able to do self-directed research for 4 years. Like, if that is your jam, then do a PhD because that's what it is. And you should do it because you enjoy that activity, not because you want the outcome of where that gets you at the end. You should do it. I mean, honestly, that's true of anything, right? Like, do it because you enjoy it. Don't do it just for the result. Obviously, we don't always have that choice. We have to do plenty of things in life that we don't want to do. But like, I personally prefer to try and optimize my life for enjoying the day to day rather than, maximizing the eventual outcome.
Yeah, and so far it has worked great for you. Yeah.
It definitely could be worse.
So it already answers my next question. So I wanted to ask, is it beneficial to get a PhD if you would like to be a regular DSP engineer at an audio plugin company? But I guess like the answer is the same, right? So like you need to decide for yourself. And then at some companies it may be beneficial, but at the same time, you really need to enjoy this to devote these 4 years of your life to doing a PhD.
Yeah, exactly. I mean, most of the time, if you're comparing a PhD candidate with someone who has like 5 years of industry experience, then you would consider the PhD person more junior, like for an industry role. Not always, but most of the time. So you do sacrifice something to do the PhD, potentially. I mean, that's another reason why I'm saying that you should do it because you enjoy it.
Yeah, I totally agree. And like, since still staying in the topic of research, I wanted to ask for people from the outside, what are the technologies and programming languages that are used currently for AI research and machine learning research in audio?
Python.
Okay, period.
Python. Yeah, I mean, Python sucks. Now I'll get Python people hating me in the comments. But it's what is used. Like, it's the standard. I mean, there's still a little bit of discussion, I guess, TensorFlow, Keras versus PyTorch, but mainly it's all PyTorch in Python. Or JAX as well. JAX from Google is quite a nice language. But you need to be able to read PyTorch at least, because that's where all the latest research is usually published. And most companies will probably have a PyTorch-based tech stack. It's also, I feel like C++ knowledge is still useful and important, especially talking to your audience of like audio people, because they might have that knowledge already. That's not a common skill amongst people coming from a more traditional ML background. And it's still extremely important for fast inference. So that's actually a really good skill set to have. Like, especially, I mean, obviously it requires upskilling a bit if you know how to program CUDA code as well. Like this, like low level high performance programming is still massively relevant in the machine learning world, and increasingly so, I think. So yeah, if you like that nitty gritty, like to the meta programming stuff, and want to work in AI, but you're currently doing audio or something, like that's not a bad thing to focus on at all. Like that's quite an in-demand skill set.
Okay, that's really interesting and not entirely obvious, I would say, from the outside. But that there's also this. There's also this emerging field of this MLOps space, right? So like people who are working on an infrastructure for machine learning, machinery,
Absolutely.
and inference.
I cannot pretend to understand the internals of everything that goes on there. I obviously interact with these people all the time because they're making my work possible and my life easier.
Okay, and I have a last question on research topics. So I wanted to ask maybe more of your opinion than on simply the facts. How is you feel audio different in generative AI than text or images?
I mean, in a way, it's not, but it also is. I mean, all of these modalities have different structures in a way, right? Different levels of redundancy, and different considerations that you need to make if you want to build models in that space. I mean, I suppose images and audio are, I feel, more similar. Text is a totally different thing because text is an incredibly compressed representation. And most of the like work of decoding that representation is done in our brains. So a big part of the kind of important work going on in generative modeling research at the moment is actually closing that gap. So trying to make representations for audio or representations for video or for images that are as compressed and semantically rich as text is. Because that's a big gap to close. I mean, like, if you think about like one sentence, I don't know, like from a poem or something, like maybe 6 words, and the amount of information that's expressed in that and how much data is needed to represent it, it's like almost nothing. And then you think about that same like sentence as, well, even like 16 kilohertz or audio or something, like it's not just a couple of orders of magnitude. It's like, I don't know, 5-6 orders of magnitude bigger. So yeah, trying to get these different modalities into a space that is as compressed and semantically rich as text is one of the main research challenges of this area at the moment, I would say. And something that people are making big strides on.
Nice. Okay, that concludes our more technical questions, and at the end I have a little bit of fun questions, you could say. So
okay, sure.
one thing that I wanted to ask you is that I've seen you doing, a great number of educational talks on audio research, and some of these talks are also published on YouTube. And I'm just curious, like, is it a legacy of your PhD that you enjoyed teaching, or is it more your attitude about, sharing the work that is out there and helping out others to advance?
Yeah, I mean, I like sharing stuff. I mean, if I did talks and nobody listened and nobody got anything from it, then I guess it wouldn't be that gratifying, but that's not usually been the case. People love to, like, people love it when you share what knowledge you have, right? And I think that I mean, I guess in a way you could relate it to the PhD. Like, even if you're not a professor or whatever, it's part of the like the contract of being a researcher or being like partly an academic, that you spread knowledge and you like try and build other people up to continue the work in the space once you're gone. Like, that's just, it's like the Hippocratic oath for doctors, right? Like, if you're doing research, then you got to do a little bit of teaching. Like, that's just the way it is. That might not always be lectures. That might be like mentoring or like stuff that's done one-on-one. But I feel like it's just part of it. I mean, it's also very rewarding personally when you can, give something to someone that makes even a little bit of impact on them. And to be honest, you often learn stuff on the way. Like, I mean, this is a common cliche, right? Like, to be able to teach something, you often need to understand it way more deeply than you thought you did when you started trying to teach it. So, it's also never a bad way of like deepening your own knowledge and like organizing your thoughts a little bit. So, I mean, and it's also, to be honest, I don't necessarily seek out these opportunities actively. People just ask me to do stuff. So I do it. It feels good to be giving something back. So as long as people keep asking me to do stuff, then I will continue to do it.
Awesome. And yeah, I'm happy to see you on the podcast in this vein as well.
Yeah, absolutely. Happy to be here.
And the maybe next question is related also to everything we've discussed today, which I'm amazed about is how are you able, to maintain such a high degree of focus needed for research and programming work? And here, I know you mentioned this diffused mode of thinking, so the place where creative ideas happen, but to read papers and to understand them and to learn especially completely new concepts, you really need to focus. So that's my question. Like, do you work, do you make home office or do you work in office, and how are you able then to focus?
I mean, I like both. I mean, for focused learning, it's obviously better to be home office. But for collaboration and developing new ideas, it's nice to be around people and like bounce stuff back and forth and write things on a blackboard. I mean, different stages of a project require different environments, right? I think that's it. I mean, part of it is just enjoying and being interested in the thing, right? Like, I don't find it like challenging to force myself to read papers or something. Like, I'm interested, I want to read it. Like, I'm just as interested as I am in watching like the TV show or looking at the news, or well, more so probably, to be honest. So like, yeah, I mean, I feel like if you enjoy the topic and you're interested in it, then it will come kind of naturally, that focus. And if it doesn't, then, well, actually, I don't know. I'm sure there's plenty of people who really love a topic but then have problems focusing. So I don't want to say it should always come easily. But for me personally, I've just found, I like it. So the burden of trying to do it is not too great. And it's not like I'm working like insane long hours or anything, to be honest. So I guess I developed a skill over time of like not wasting work time. Like, when I'm working, I'm 100% working. I'm not checking my phone every 2 minutes. I'm not like looking at some website on the side. I'm just, in it. And to be honest, if you focus like that, then you don't have to work like 10 hours a day or something. Like, you get a hell of a lot done in a short amount of time. And I actually think that's the natural way of working. Like, I feel like, unfortunately, well, okay, it's not been like that at most of the companies that I've worked for. A lot of companies equate time with productivity. I don't think that is actually really the way people work. Like, I think the most efficient and the most productive way to be is to like work intensively and then rest, like do something else, like let the ideas percolate, like go for a walk, go and like look at the sea, or you know what I mean? Like, we're better at like sprinting intellectually than we are at running marathons, I guess is a way of looking at it. Like, if you can have like super productive 3 or 4 hours a day, or even less, then you'll be good. Just don't sit there banging your head against the computer when you're not getting anything done, because that's only going to make everything worse. I know that's not possible for everyone, especially if you're working in a really traditional office environment. I'm very privileged to have been in places where people care about the output rather than the hours worked, so I can take that. I can take that approach. And honestly, if I'm like, if it's about like what I would recommend to other people, like, yeah, I mean, if you're able to work in that way, then in my experience, it's the most productive.
Okay, thanks. I think it's a very precious advice to then focus on what you want to work on the given day for maybe a shorter amount of time, rather than working in this kind of semi-distracted mode for 8 hours straight.
Exactly.
Yeah. Okay, and then when you're done with your work, how do you disengage personally?
I mean, all kinds of things. I still make music. I mean, sometimes the boundaries between that. So sometimes I make a lot of music and sometimes I don't make any, partly because sometimes it feels too close to the day job and I want a bit of separation. Actually, that's one of the reasons I really got into playing the guitar over the pandemic, because like working on music tech, then making like very technically focused like synth stuff, it felt too close to the day job and I wanted a bit of separation. Whereas like sitting and just doing a purely physical activity like playing the guitar felt like something else, and like, but still musical. So, I've increasingly been doing that for that reason. I mean, apart from that, it's just all the normal cliched stuff, right? Like I spend time with my partner. I mean, I do a lot of walking actually, like both like hiking out in the nature, but to be honest, so I live in London now. I like, will do dumb things like take the tube out to the end of the line and then just walk off on a footpath into the fields and see where it takes me for a few hours or something. Like, I don't know, I just try and, be present in the moment and just, be in the world and, relax in that way. Does that make sense?
Yeah, definitely. And it's I think it's encouraging that seeing you not work, 24/7, but rather,
I mean,
take your time.
Part of what I was saying before, though, is that like when you think you're not working, you actually are working, because your brain is subconsciously putting the pieces together. So it's often when you're not working that you make the most progress. It's weird the way that happens, but it just, in my experience, that is the way it happens. So you need to give space for this stuff to happen.
Okay, and does it mean that you don't listen to music when you're working, when you're programming or doing research?
Yeah, mostly not actually. I mean, that's also just so over the years, I've had to develop a very analytical ear, I suppose. And it can be difficult to switch that into passive mode. So certain kinds of music I enjoy working to, but it has to be very abstract, potentially, maybe even more like ambient and drony stuff can work. Sometimes like rhythmic stuff that is quite repetitive, like, I don't know, more minimal techno stuff or something. But in general, to be honest, no, like I don't tend to listen. I mean, that's maybe also because often in my work, I have to listen to something to do with the work. So if you've got a track on and you're constantly stopping it to listen to this other thing, maybe it's also about ear fatigue, to be honest, because like your ears do get tired. That's another reason why if you're doing intense listening work, you can't do like 10 hours a day. Like it doesn't work. Like you stop hearing things properly. It's the same as like eye fatigue or whatever. Like at some point you're not hearing things correctly anymore. And in a way, if you want to listen critically, then it's good to have silence. in the times when you don't need to be listening. I mean, the advent of noise cancelling headphones has been great for this to me, to be honest. Like, I love just putting them on, switching off the outside world, and then that's like a space in which you can focus.
Yeah, I definitely agree there. Okay, and since you've lived in Finland, you lived in Berlin, you now live in London, and you maybe lived somewhere else as well. So, of all the cities that you've lived in so far, is there anyone that you would pick as your favorite?
No, it's like asking someone what their favorite child is or something. Like they all have their own advantages. They all have different things that are great and different things that are not great. I mean, every place that I've lived, even my hometown, I've got plenty out of. So, I mean, I do very much like Finland. I would like to go back there someday for many reasons. I never thought I would move to London, to be honest, because I'm not a Londoner. I'm from a different part of the UK. And it never really felt like my place somehow, but now I'm here, and particularly in the bit of London that I live in, like, it's great. Love it. So I don't know. You can always find things to like about a place, right? Yeah. I mean, for me, the most important thing is that it's not too car reliant, and, has a bit of nature available. Maybe that restricts you quite a lot, actually. But certainly the places that I've lived are are all those things.
Awesome. So that concludes our huge list of questions. Thank you so much for this interview. I got a lot of notes. I think the viewers also got a lot of information. And if someone of the viewers wanted to contact you, is there any place that you recommend they go?
I mean, I tend to not share my email so much because of spam, which is sad, but it's an unfortunate consequence of the modern world. I mean, I would suggest people hit me up on LinkedIn. So I wouldn't say I was like a super active user, but it's a pretty good place for talking to other people in research these days, and connecting with people. I know some people like Twitter. I've never really been a Twitter person, to be honest. So that's not a good place to reach me. So yeah, maybe LinkedIn. I mean, also I'm on the Harmony Discord that I mentioned earlier. So if you want to jump on Discord and send me a private message, then I will see that and probably respond as well. So, those are probably the current places to get me.
Okay, awesome. Thank you so much. Thank you so much for this interview, for your time, for all the knowledge and tips you've shared. I think the viewers will appreciate it a lot, and I definitely have, and I'll also try to put all the tips into practice. And you definitely spark this generative music itch to push this branch and learn more about this. So thank you once again, and I wish you all the best for all your future endeavors.
You're welcome. It's been a pleasure.
All right, everyone. That was Julian Parker. Thank you so much, Julian, for being so generous with your time and sharing your knowledge. To you, dear listener, all the people, places, and references mentioned in this podcast episode can be found in the episode notes at thewolfsound.com/talk025. Once again, it's thewolfsound.com/talk025. And if you enjoyed this episode, and if you'd like to support the podcast somehow, then please consider subscribing to the WolfSound channel on YouTube, giving a thumbs up to this video, turning notifications, and also consider giving the WolfTalk podcast a 5-star review on Apple Podcasts or on Spotify. If there's someone you'd like to see on the show, you can suggest such a person in the comments on YouTube. Finally, don't forget, about your free resource, the audio plugin developer checklist at thewolfsound.com/checklist, and I will see you in the next podcast episode. Thanks for watching, thanks for listening, and take care.